Hello guys, welcome back for another lesson. So the topic today is solving rational equations. Of course, you know, algebra is all about solving equations. You start out early and that's, the majority of what you do. Isolate the variables, solve for x, stuff like that. Rational equations are generally covered in Algebra 2. This being pre-calculus, prepare you for the potential of calculus. Generally, when you get to calculus, you need to have a repertoire, sort of a toolbox ready to do sort of any kind of math that's thrown at you. So being able to look at a rational equation, just know how to solve it and carry it out is something that is kind of expected. So a rational equation is an equation with at least one fractional expression in it, and the variable is in the denominator. So if you see that, it's going to be a rational equation. I'm going to use a strategy. There's different ways to do this. I'm going to use a strategy called clearing the denominators, sometimes referred to as clearing the fractions. Essentially, you multiply all terms in the equation by the lowest common denominator, LCD. Now, like with regular fractions, there's times you generally always want to use the lowest common denominator. There's times where any common denominator will work. That's kind of the case here. I'm always going to go with the LCD, the lowest common denominator. It's usually pretty easy to figure out. Sometimes it can be a challenge. But when you do this process, basically all the denominators in the equation will cancel. They'll just disappear. And then your equation won't be a rational equation anymore. It'll just be a regular equation. And you can use basic algebra on it. So this method, this clearing the denominators, turns the equation from a rational into sort of a regular equation that you can work out. Now, as usual, I'm going to do the evens and ask you to do the odds. After one or two examples, you might feel like you get it and you want to stop and move on to your homework. I will tell you that right around number 8, it gets a bit more complicated. So if you get number 2, you could probably get away with skipping ahead maybe to number 8 and then 10, 12, 14. So you see there's 7 total. If you don't want to sit through all 7, I understand, but don't just watch the first one because that might not be enough. So, all right, here we go. So this is a rational equation. It's made up of at least one fraction with variable in the denominator. So this we want to solve. We're going to multiply the whole thing using the distributive property by the common denominator. So if you look at the denominators, there's 5n, 5, and 5n. The common denominator for this, the LCD, is going to work out to be 5n. It's got the components of all the denominators. When I say components, actually I should be using the correct terminology. It has all the factors of all of the denominators, 5 and n. Okay, so here's what you do. You multiply this whole equation by 5n, and we are going to use the distributive property. So we're going to distribute this here to that term. So it'll look like this, 5n times n minus 1 over 5n. Then you bring down the equal sign, and you distribute here. 5n times 1/5. Bring down the minus sign and distribute here. 5n times n minus 2 over 5n. So this has been multiplied by all 3 of those terms. I'm doing a lot of highlighting today. Now, what happens? Well, just like with regular numbers, if you take a fraction like 5/7, I don't know, you multiply it by a whole number, maybe you want to multiply it by 3, you put the 3 over 1 and just go top times top, bottom times bottom. Unless, let me change it a little bit, unless, let's say you had 5/3 and you multiply that by 3, you put the 3 over 1, and then those 3's cancel, leaving you with 5 over 1, and then it turns out over 1 doesn't really matter. You just ignore that and you get 5. So that's what's going to happen here. You can put this over 1 and those cancel out. You get n minus 1. Put this over 1. Here the 5's cancel out, leaving you with n times 1. n times 1 is just n. And then for the next term, now this is going to be a little tricky. So the 5n cancels with that 5n, and that leaves you with minus n minus 2. Now, if you write down minus n minus 2, it's actually wrong. Here's the situation. This negative sign affects the n and the minus 2. So we have, in essence here, a minus minus. When you minus a negative, you know it turns to plus. So that's one little detail. So every so often you get a double negative in here, and it's easy to overlook it. So you got to be sure you stay on top of that sort of thing. But once you've done that right, if you look at what's left, that's a real basic equation. N minus 1 equals, okay, n minus n cancels out, equals 2. Add 1 to both sides, n equals 3. And that's the answer. Now, if you go back to the instructions, it says remember to check for extraneous solutions. Basically, remember that in fractions, you can never have 0 on the denominator. That's called undefined. You're not allowed to have that. So the question is, if you plugged a 3 in, would that give you a 0 in the denominator? No, it gives you a 15 in the denominator. No big deal. So that's not extraneous at all. In fact, I don't think this whole worksheet has any extraneous solutions. I might be wrong. But anyway, there's a number 2, 3. Let's do the next one. So the common denominator, the LCD here, it's got to have all of the factors of all of the denominators. So all of the denominators clearly have r squared, so that's got to be part of the common denominator. Then we got the 2 and the 4. So which one of those goes here? The 2 or the 4? You got your best guess? Do you think you know the answer? 4. So 2 is common to both of them, but we need all of the factors. And 4 is made up of a 2 and then another 2, and we have to include them both. Just like for r squared, we included both r's, not just one r. So that is that. Now, if you mistakenly chose 2 squared, 2r squared, when you distribute it, let's say like right here, it'll cancel out, everything will be good. But when you distribute it to this one, let me squeeze it in there, the r squares would cancel, but the 2 would not completely cancel, leave a 2 on the bottom. So when it comes to the numbers, you basically generally want to pick the larger of the 2 numbers, or even multiply them together sometimes. Anyway, I'm getting a little off track. So 4r squared is our common denominator. We want to multiply this whole thing by 4r squared. Now I can do what I did up here, where I basically, I distribute here, I write 4r squared times 5 over r squared, bring down the equal sign, da-da-da-da-da-da. There is a little, I don't know, trick, shortcut, step, skip step, I don't know. Something to make you do less writing. It just depends on how neat you want it to be. But since you see 1, 2, 3 terms here, they all need to get multiplied by the common denominator, 4r squared. You can just, what did I do? What the heck? I don't know how I did that. You can just, what is going on? Oh, I see. I accidentally tapped something. Okay. Anyway, you can multiply each term by 4r squared. Just kind of squeeze it in like this, if you like. There's really no need to put all of them over 1. I mean, you could if you want to, but you don't. It doesn't really serve any purpose. When you write it in like this, sort of squeeze it in, you can cancel the r squared and the r squared. You're left with 5 times 4. See right here, 5 times 4. That's 20. And then this completely cancels out. You bring down r minus 2. And then this cancels. 2 goes into 4 twice, so that leaves you with minus 1 times 2. 1 times 2 is 2. And there it is. Now a very simple equation that you should not have any trouble solving. Minus 2, that's minus 4. Add 4 to both sides. 24 equals r. That should be the answer. Can you plug 24 back into the original equation? Yeah, you're not going to get undefined anywhere. So that's not what we'd call an extraneous solution. And there we go. All right, next one. Here it is. There are only 2 denominators, and they are both the same. So in this one, the LCD is going to be x minus 8. So we need to multiply this term by x minus 8, this term times x minus 8, and this term times x minus 8. Now, don't get tempted to like FOIL this all together and make a big mess. I mean, you could do that, but boy, since this cancels with this, you don't want to FOIL it. I mean, that cancels with that. They're just gone. Now, you will have to distribute this term, so 7x minus 56. And then here you've got, well, okay, if this cancels with that, that's just 2x minus 12. And those cancel, bring down a minus 1. And then from here, not so bad. So 7x minus 56 equals 2x minus 13. Get like terms together, so I'm going to subtract the variables first. 5x minus 56 equals negative 13. Add 56 to both sides. 5x equals, what, 43? Boy, I'm sure hoping I'm doing my math right. Divide by 5. Of course, 43 doesn't divide by 5. Just leave that as a fraction. And is that the right answer? There it is, 43/5. So far so good. We had fairly easy common denominators to figure out. One where there was just one denominator, so by default it's the common denominator. And then we get to one like this, number 8. And your number 7 is going to be a little bit like my number 8 here. And these are fairly complicated denominators. They're binomials. They're like, I mean, you know, when they're monomials, it's pretty easy. This one was binomials, but they were identical, so it wasn't that tough. But if you don't know what I'm talking about, binomial means two terms, either added or subtracted. Two terms, two terms. Okay, so what we need to do here is rewrite the problem with factored denominators. Hold on. I like to get that nice straight line. Okay, so factor the denominators. If I factor the first denominator, I can factor out a 6p, and that's going to leave me with 3p plus 1. If I factor the next denominator, I can bring out a 2p, and that's going to leave me with 3p plus 1. And then the other final denominator, I can factor out a 6, and that's 3p plus 1. So now to find the LCD, every denominator has a 3p plus 1 in it. Some of the denominators have p, so that means we need p to make it a common denominator. And then 6, 2, and 6, like before, you pick the higher number, as long as 2 divides into 6, and it does. So our common denominator we need to multiply everything by is 6p parenthesis 3p plus 1. So I'm going to go times 6p 3p plus 1 times 6p 3p plus 1 times 6p 3p plus 1. So multiply every term by that common denominator. First, everything cancels and we bring down a 1. Next, let's see, the 3p plus 1 cancels, the p cancels, 2 cancels with 6, but it's going to leave a 3. So what we have to bring down here is p plus 4 times 3. I could have done that step in my head, but yeah, I'm not going to. In fact, I'm going to rewrite it, because normally when we distribute, we put the number in front, so that makes a little more sense. And then this other term, the 6 cancels, the 3p plus 1 cancels, leaves me with 1 times p. So I can just make that a p. That's nothing I need to carry down. Next, I have to distribute, and keep in mind that negative sign distributes with it. So 1 minus 3p minus 12 equals p. Pause there for a second. Okay, I think I'm doing okay. I'll get like terms together, so I'm going to add 3p to both sides. 1 minus 12 equals 4p. 1 minus 12, of course, is negative 11. And divide by 4. I sure hope the answer is negative 11/4. If it's not, I may just shed a tear. Oh, brilliant. Negative 11/4. All right, so that was a pretty complicated one. Number 10 is not quite as bad, but sort of along those lines. V minus 7 over V minus, I'm going to factor this denominator. I can factor out a V equals 1. So my LCD here, it's got to have all the terms in it. So both of these have a V. This term has a V plus 7. So that's going to be my common denominator. I highlight too much. I don't know. All right, so multiply this one. Here, I'll do it on the left. V times V plus 7. Multiply this one times V plus V, or V, sorry, times V plus 7. And multiply this term, V times V plus 7. Okay, what do we got here? Those cancel, and that gives me V plus 7, V minus 7, minus. Here, next, everything cancels, so just a 1. And then here I get 1 times V, V plus 7. Okay, well, I've got some work to do here. I need to FOIL this together. That's V squared minus 7V plus 7V minus 49 minus 1. Here's V squared plus 7V. If I simplify the left-hand side, minus 7V plus 7V cancels out. Minus 49 minus 1 is minus 50. Let me get my V squared terms together. They're like terms, and that's kind of nice. They just cancel out. Negative 50 equals 7V. Divide both sides by 7, and I am done. Negative 50 over 7. And I got to peek at the answer before I started. I think that was right. Yep. Next problem is going to have 2 answers. How can that happen? Let's look at number 12. Okay, once again, there's only one denominator, so that is by default the common denominator. So I need to multiply everything by m minus 3. Let me move that over. So this term gets multiplied by m minus 3. This term gets multiplied by m minus 3. This 2 gets multiplied by m minus 3. And this m gets multiplied by m minus 3. So what happens here? Well, this cancels out. This cancels out. On the left, nothing really cancels, so I'm just going to bring down m times m minus 3 plus 2 times m minus 3 equals 1. And let me clear that up a little bit. Yep, that is a minus sign, 7m. So do you see what all happened there? Now, distribute this, m squared minus 3m. Distribute that, plus 2m minus 6 equals 1 minus 7m. Those are like terms. M squared minus 3 plus 2 is minus 1. Now, when you solve a second degree polynomial, also called a quadratic, you need one side to equal 0, so I can add 7m over to here. I can also go ahead and subtract 1 over to there, just do it all in one shot. M squared plus 6m minus 7 equals 0. To solve a quadratic, you could use the quadratic formula if you want, a, b, and c, all that stuff. Probably easier just to factor this one because 1 times 7 is 7. Negative 1 times positive 7 is negative 7, and it adds up to 6m. Set each factor equal to 0, and then you get plus 1, m equals 1, minus 7, m equals negative 7. So positive 1 and negative 7 are the 2 answers. Yes, they are. All right, one more and we are done. This is another one where it would be good to factor the denominator before you start. So this is p plus 3 equals 1 over p plus 3 minus 1. My lowest common denominator has to have, of course, p plus 3 in it. But since this denominator also has the variable p, we need that factor in as well. So multiply everything times p plus 3 times p plus 3 times p plus 3. That way everything here cancels. I can bring down a 1. The p plus 3 cancels there. I can bring down 1 times p, which of course is just p. And the last term here, nothing cancels, but I can distribute, well, you know what I'm going to do? Negative 1 times p, negative p plus 3. So I just went ahead and multiplied the 1 and the p together. Now I need to distribute this. So that's negative p squared minus 3p. Okay, so 1 equals, I got p minus 3p, like terms, minus 2p minus p squared. Again, we have a quadratic. We need one side to equal 0, so I'm going to go ahead and add p squared to bring it over to here. And I'm going to add 2p. So that's going to give me all my terms on the left, p squared plus 2p plus 1. And everything cancels over here, 0. This is pretty easy to factor, isn't it? P times p, 1 times 1, 1 plus 1 is 2. Technically, you're supposed to set each one of these equal to 0, but of course they're the same, so when you solve them, you're going to get the same answer, p equals negative 1. So p equals negative 1 is the answer. You don't really have to write it down twice, and there it is. And we didn't have any extraneous solutions, so there's no numbers you could plug back in. I mean, theoretically, let's say you work this all out, this last problem, and you got p equals negative 3 for an answer. Just pretend that somehow worked. Well, if you try to plug that back into the original equation right here, you get negative 3 plus 3, which is 0. 1 over 0 is undefined, so you would have to throw that solution out. It would be extraneous. It just doesn't come up on this worksheet. So if it doesn't come up on the worksheet, it won't come up on the test. You don't need to worry about that too much. But yeah, there it is. So do your best on the odds. If you have any trouble, I really did design this so that they kind of go together, the examples. I think there's one exception where number 9 is not totally like number 10. Hopefully you can still figure it out. If you have trouble, let me know. This can be one that I go over on Friday, that we do our Google Meet, if anyone needs help with that. So, all right, I'll stop here and I'll talk to you again real soon.